Again, welcome to EGN 2712, Applied Programming for Engineers. Okay, and as I have said no earlier, no, I mean yesterday that this course is we're going to talk about all the time about C++ programming and also the MATLAB programming. Okay, so now our first topic for today, now for the CLO1, is all about algorithms and flowcharts. Okay, so most likely algorithms are and flowcharts are they are in tandem together, no? In tandem together, meaning they are in together, so that we can understand the flow of the program. Okay, so now. So what is algorithm, no, and flowcharts? So from the definition, algorithm is a step-by-step procedure to solve a given problem, and a flowchart is the graphical representation of the algorithm. Okay, it will show you the step by steps, no, involved in that algorithm. Okay, so so what are the good qualities, no, of an algorithm? So algorithm, it should have an input and output, of course, and it should be defined precisely. Okay. And number two, each step in algorithm should be clear and unambiguous. Okay. It should be clear. So not changing, it should be unambiguous. Okay. And algorithm should be most effective among many different ways to solve a problem. And algorithm shouldn't include computer code. Okay, so we are not writing computer code, no. Whenever we are trying to define, no, or to know about algorithms, so no computer code at all. So instead, the algorithm should be written in such a way that it can be used in different programming language. Okay. Now, for example, no, one example of a algorithm, no, uh, everyday routine, no, in our life, no. For example, no, drinking coffee. Okay, so in drinking coffee, we can do a algorithm out of it. Okay, so how to drink coffee? Okay, so what are the steps, no, in order for you to drink your coffee? So first step you need to do, take a coffee pad. Okay, the pad. Okay, and then put it in the coffee machine. Okay, that's step number two. Then check if the coffee machine is turned on. Okay, if turned on, or if not, then turn the machine on. Okay, if turned on, then you can proceed to step number four, which is check if the water filter is full enough. Okay, then if not, if the water filter is not full, then you need to add water. Okay, if full, then it will go to the step number five directly. Okay, then put a coffee mug under the coffee dispenser, and then you need to press the coffee button. Okay, then once you press the coffee button, step number seven, the coffee is being served, and wait for the machine to indicate when the coffee is ready. Okay, and step number eight, if the coffee is ready, then take the coffee mug out of the coffee machine. Then if you are fond of the adding milk or sugar, then you can add on it, and voila, congratulations, you can now drink your coffee. So algorithm is ready. Okay, so this is how algorithm works, no? It's a step by step procedure to solve a given problem. Okay, in most specifically, no, for our daily routine, no, or in daily lives, no. For example, no, if you're going to school, okay, so what you need to do, no, to go to school, okay. So of course, no, step one, you need to have, you need to, no, if you have a car, no, if you are going to school with a car, so you need to open the door of your car. Okay, number two, switch on the car, and then number three, drive the car, and then when you are arrived at the the school, then switch off the car and get out from the car. Okay, so that is another one example of a algorithm. All right. So another example is daily routine is that washing your hands. Wash your hands. Okay, so we can also make an algorithm out of it. Okay, so step number one, open the water tap. Okay, and then put soap on your hands. Okay, and then number three, clean your hands with water. And then number four, shut down the water tap. Okay, and last is the dry your hands. Okay, so this is the everyday routine that you are encountering during the day using algorithm. Okay, so you can make an algorithm out of it. So next is, for example, now let us say we're going to add two numbers, okay, that entered by the user. Okay, so we can make an algorithm out of it. So let's say step number one. Step number one, of course, you need to start. Step number two, declare the variables num1, num2, and the sum. Okay, why you need num1, num2, and sum? No? Num1 represents the first number, num2 represents the second number, and sum is the addition of num1 and num2. Okay, then step 3, read values num1 and num2. Okay, and step 4, add num1 and num2 and assign the result to sum. So sum is equal to num1 plus num2, and then display the sum, then stop. Okay, so here how it will be. So num1, so you enter 25, for example, and num2, you enter 35, for example. Get the sum by adding num1 and num2. Then you'll get the sum is equal to 60. Okay, and stop the algorithm. All right. So these are the simple examples of the algorithm for you to understand clearly what is algorithm all about. Okay. Now we define algorithms and got some examples out of it. Now we need to represent this algorithm in order for us as a programmer or as studying programming. We need to represent it using graphical representation, and it is called flowchart. Okay, flowchart. All right. So what are the basic flowchart symbols available in flowchart? Okay. All right. So basic flowchart symbols. So in order for us to understand what is flowcharting, how to draw flowcharts, we need to know the basic flowchart symbols. Okay. So here are the basic flowchart symbols. Like for this one, this is like an oval shape. Okay. This is not a square. It's like an oval shape. Okay. Like that. Like an oblong. Like that. And it is called the terminator. It's where you will going to start. You're going to use it as a start and as a stop of your flowchart. Okay. Then next you have this preparation symbol, like an hexagonal shape. Okay, we call it preparation, where you can declare your variables, and also the characters or strings that you want to use during your flowcharting. Okay, so it's where you can prepare your variables mainly. All right. Then another symbol is this one, the rectangular shape. Okay, so rectangular shape is a process. We call it process. Normally, we are putting it there the formula, or the equations, of the program. Okay, or the flowchart. All right. Then we have this decision, like a diamond shape. Okay, we call it decision. So this is where you can write the condition of the flowchart or condition of the problem. Okay, like for example, if A is greater than or equal to 10, or then if it is greater than, if A is greater than or equal to 10, then true. If not, then false. Okay, so this is where you can use the if else, no, if else or decision making flow charting or programming. Then we have the input and output, no, the parallelogram shape. Okay, this is an input output where you can input your data, no, to a variable to store a data into a variable, and then where also you can use as an output or to print, no, to print to print the output or to print the value or the data of a certain variable. Okay, and then we have here this predefined process or function. Okay, if you want to create a function, no, in your flow charting, so you will be needing this, no. Okay, and you have also the documentation. If you want to print out, for example, no, in your flow chart, that this flow chart or this algorithms, okay, or this problem needs to be printed out using flowchart, then you need to use this documentation symbol. And then this circle is an on-page connector. Okay, on-page connector. All right. For example, no, your flowchart is very long, no, and then it cannot be, no, what you call this, cannot be fit, no, in your paper. Then you need another page. Okay, okay, another page. Okay, for example, no, in your paper that you want to make a multiple flow chart there, no. Okay, then you want to connect that flow chart, no, inside that paper, in the same paper, then you can use this on page connector. But if it is outside, no, you're making another flow chart that you want to connect it, no, to your first flow chart, then you need to use this off page connector. Okay, and then last but not the least, the direction or flow of your flow chart, oh, the arrow, no, this arrow. Okay, this is the most famous one. So with this you can see the flow of your flow chart. Okay, so now there are three basic flow charting constructions available, no, in C++ programming or in any programming, no, in any programming language. It's either maybe Java or C program or MATLAB or any program. So these three basic flow charting constructions are available. Okay, so we have the sequence, we have the selection, and we have the repetition. Okay, so sequence, selection, and repetition. Okay, sequence is just it's like a sequential, no, flow charting. So meaning to say it will start from the top, okay, and to bottom. Okay, it's like just a straight line. Okay, straight arrow, no, from top, no, the arrow is pointing from the top to bottom. Okay, this is the most simplest, no, flow chart, no, flow charting constructions, no, ever used, no, in programming languages. Okay, so we have also the selection or decision making, okay, or selection, where you can use, no, this diamond symbol. No, what is the diamond symbol, by the way, girls? What is diamond symbol?
Decision.
Decision. Okay, so this decision here, diamond symbol, will tell you whether if the condition is satisfied or not. If it is satisfied, then it will go to true. Okay, if it is true, then it will go to this side and execute this, what do you call this, the process, no, this process symbol, and then it will go to this symbol. Okay, another process symbol. So like that, no? If it is false, meaning if not satisfied the condition inside the decision symbol, then it will be false. Then this will be executed, and it will be executed. Okay? So can you see the flow? So coming from here, and then it will check whether the condition is true or false. If it is true, then it will go to the left side, and if it is false, then the flow will go to the right side. Okay. Then last but not the least, the repetition. Okay. So repetition is something like looping. Okay. It will loop. No? It will loop loop every now and then. It will loop every time until it will no it will say that the condition is false, then it will stop the looping. Okay, so this is one example here. No, so the flow is coming from the top, then it will process, okay, using this process symbol, and then after processing it, it will check the condition. If the condition is true, then it will process this B. No, this process B, it will process it, and then it will go back here to do the process A again, and then it will check the symbol again. If it is true, then it will process this B again, and it will go back to A again, until such time if the decision is false, then it will exit, no, from the flow of the flowchart. Okay, so it will keep repeating and repeating and repeating until it will arrive in a decision or a condition that is false. Okay, so remember these sequences. So remember these flowcharting constructions. We have the sequence, the selection, and the repetition. Okay, so now let's have an example. Okay, so this is an example of a flowchart. All right, so sequence. Okay, for the sequence. Okay, so draw a flowchart that will ask the user. It will ask the user to input two numbers, and will print the sum and product of these two numbers. Okay, so sample display. So input two numbers. Okay, and press enter. So the two numbers are 2.5 and 6. Okay, 2.5 and 6. Okay, so these two numbers will be added together, and it will be also multiplied, no, together. Okay, so the product, you're going to take the sum, the addition, and the multiplication of these two numbers. Okay, so for the sum is equal to 2.5 plus 6, so it will be 8.5, and the product 2.5 times 6, it will be 15. Okay, so this is the sample display, no, in the flowchart, in your program or in your flowcharting. Okay, all right, so this is the flowchart of this problem. Okay, so of course, no, the flowchart will start with a start symbol. Okay, this oblong shape, no, like an oval shape. Okay, so start, and then arrow will pointed here, no, will point where will be pointing, no, to this hexagon shape. Okay, where you can do your preparation. Okay, this is the preparation symbol. Okay, here where you will declare, no, the variables, no. So how many variables are you going to use? Okay, how many? Tell me. How many variables you're going to use? Girls, how many? Remember, in your problem, it's asking the two numbers. Okay, two numbers. So how many variables you need? Can you please tell me? Anyone, just say it. I don't want to go to the. How many? Tell me. Anyone can tell me?
Two variables.
Right. Two variables. Okay. So two variables. So we will name it as num1. Okay. This is representing this first number. First number. Okay. And num2. This is your second number. Okay. Like that. Of course, no, you need to find out, no, the addition of these two. So you need another variable. That is what we call sum. Okay, sum. And the other one is the prod. Prod, it means the variable for the product. Okay, or the multiplication. No, multiplication of two numbers, of these two numbers. Okay, so that is why here it says num1, num2, the sum, and the prod. Okay, actually you can put any variable, no problem. No, you can put here, let's say, num1. You can also make it as x1, x2, no problem. Okay, and here sum you can put it as s, then product you can put it as p. Okay, it doesn't matter, no, as long as that you are declaring the correct numbers of variables. Okay, then after declaring, no, using this declare preparation symbol, okay, after that it will go to this. No, what is this symbol, by the way? Anyone? What is this symbol?
Input output.
Input output.
Okay, input output. Okay, this time this will work as a input. Why? Because here you need to accept, no, you need to accept, no, num1 and num2, because you are going to ask the user to input first number and second number. So it's an input symbol. Okay. All right. So once you accept num1 and num2, then it will go to this process. Okay. This is process symbol, huh? Process. Okay. Process. Where you can put your equations, no? So normally process is going to process. Okay, we're going to what you call this, going to execute, no, your equations, no, like for instance, no, this equation, the sum, okay, is equal to the num1, whatever the number you inputted, plus num2. Okay, and for the product, prod is equal to the num1. And remember this, no, in C programming and C++ programming, the multiplication is asterisk. Okay, this one, no? Asterisk. This is meaning for multiply. Okay, so num1, no, star num2. Okay, or num1 times num2. Okay, and you get the prod. Then after that, there's another symbol similar to this one here, no, the top. Okay, similar, but this time this will work as a output. Okay, and then it will display or print. Okay, print the sum, or display the sum, and display the product or print the product, and then stop. Okay, so your flowchart should start with the start symbol and stop with the stop symbol. Okay, inside of this, inside this, this one, declare num1, num2, like that, start, then sum like that, display. These are all our algorithms. Okay, algorithms. Okay, so the step by step, no, step by steps procedures, no. So you're going to solve the given problem. And now, if you want to look at in a in a broader way, all right. Now, Mr. Michael, what's the relevance, no, or what's the why is it important to know the how to flow chart, no, and how to do the algorithms? Okay, so why do we need to do flow charting and do algorithms? Okay, now actually that is a good question, no? If you are questioning it in your mind right now, no? If you have a question in your mind right now, no? It's a good question. So what will be the application for this? Okay. Now the application is that, no, for example, no, I am a programmer. Okay. I am a programmer. Okay, let's go to the online GDB. All right. So please take note, online GDB is one of our online compiler, no, to compile or to process, no, our programs. Okay, or to run our programs. Okay. Let me. Okay. All right. So what will be the relevance? Okay. Now, in programming, no, if you are a programmer or if you are a developer, before you program, before you write the code, you need to write first your algorithm and your flowchart. Okay? Why? So that you have a guide. No? You have a guide, step-by-step guide of how to solve the problem, okay, using your codes. Okay? So from flowcharting, then you will translate it into programming. Okay? So I'll give you this one example only, huh? This one, so that you will understand why we need, no, why we need to do flow charting and algorithm. Okay. So for this example, no, okay, this example number one. Okay. Just don't mind first the coding, huh? The coding. I will teach you, no, the proper the basic of coding, okay, or programming later. Okay, this is only for the purpose of example. Okay. All right. Okay. In a programming, no, there should be a library, no, a header, and a main program. Okay, a header. Okay, and a main program. Okay. All right. So now here the program, the flowchart says start. Okay. Of course, we're going to start. Okay. At the first, no, at the very first after the start, very first symbol is to declare the variables. Okay. Then, of course, in the programming, you need to declare the variables. So I'm gonna declare it is a, for example, is an integer, okay, or int, no, as a data type. Later, I'm gonna discuss it to you. So integer, let's say num1, okay, num2, and then sum and prod. Okay. So now I am declaring the variables, no, as the flowchart indicated. Then after that, I need to accept, no, the values of num1 and num2. Okay. So it's an input. Okay. So I will ask the user now, cout, enter num1. Okay. So don't forget here, enter num1 and num2. Okay. And then I will going to store that value to variable num1 and num2. Okay. Enter number 1. Okay. Okay, let me rephrase it. Enter the first and second number. Second number. Okay, like that. Then I will going to store that value to num1 and num2. Okay, so whatever I inputted a value here, it will be stored in num1 and num2. Okay, so after that, what's next? After accepting it, no, from your flowchart here at the right side, then it will go to this process. So now you have this equation. Okay, so I'm gonna type this: sum is equal to num1 plus num2, like that, and prod is equal to num1 times num2. Okay, then after doing this, then I'm going to do to display, or okay, to display, to show, no, what's the value of sum and what's the value of product or prod. Okay, so see out that, and then num1. Okay, I'll do end line, see out num2, end line. Okay, then return 0 after executing it. Then it will go return to the main program or main function here. Okay, that's the meaning of return 0. Okay, so let us run this. Let us try. I hope it's okay. Okay. Okay, so here there's a problem. Okay, there's an error. You can see an error. Okay, the operator are not much. Okay, run again. Okay, so now it will ask enter the first and second number. So let us enter 6 and 3. Okay, then hit enter. Right. So now you can see that when you enter 6 and 3, okay, all right, sorry. Here, sum, no, not num1, sum and product. See, I have run again. So let's say 2.5, no, in our example, 2.5 and 6. Okay, 2.5 and 6. Okay, sorry, we need to do float because there's a decimal point, 2.5 and 6. Okay, so we have here answer 8.5 and 15. So the sum 2.5 plus 6, 8.5, and the multiplication of two numbers 2.5 and 6 is 15. Okay, so the point here that I'm showing it to you, the 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 importance of flow charting in your programming. Okay, why is it we need to learn flow charting and algorithm? It's because it will be easy for us, no, to follow or to write the code, as well as also in troubleshooting, no, troubleshooting, or to find the errors in your program. Okay, is it clear, girls? Clear?
Yes, sir, it's clear.
Okay, clear. All right, so let us go to this second example, okay, for the sequence. So draw a flowchart of an algorithm that will ask the user to input a temperature in Fahrenheit, which is then converted to Celsius and printed. Okay, so this example is to convert the Fahrenheit, okay, which is the, okay, Fahrenheit into Celsius. Okay, temperature conversion, no, from Fahrenheit to Celsius. Okay, so sample display. enter temperature in Fahrenheit to be converted. He entered 32, and the temperature in centigrade is 0. Okay, so this should be the display. Okay, okay, let's check the flow chart. So this is the flow chart. Okay, so first it will start, okay, using the start symbol or the oval or oval shape symbol. Then declare, no, this declare, this is this is wrong spelling. So it should be declare the variable temp f, comma, variable temp c. Okay, and then after that, accept the value of temp f. Okay, because you need to convert the value of temp f, no, into temperature, no, degrees Celsius. Okay, and after that, it will be converted using this process symbol. Okay, so this is the input symbol. This is preparation. Okay, and this is process. Okay, so the equation to convert the uh, Fahrenheit to degrees Celsius. Okay, centigrade, no, Fahrenheit to centigrade. So temp C is equal to the one that you inputted, no. Here we inputted 32, no, 32. Then 32 minus 32, 0. Sa? Then multiply by 5 over 9. That is also, it will become 0. So temp C here, temp C is equal to 0. Okay? Then display temp C, which is equal to 0 in this output symbol. And then stop. Okay? Clear, everyone? All right, so we finished the sequence, no? The sequence examples, no? Flow charting. All right, so let us go now to if else, no? If else, no? Example or exercises for the if else. All right, so first, I'm going to read it. So draw a flow chart that will ask the user to input the name and grade of a student, and then the algorithm will then print the name and grade of the student plus whether they pass or fail. Okay, so the conditions are, no, this time we are using if else, okay, or the selection, no, selection flow charting constructs. Okay, so the conditions, if your grade is less than 60, then you are fail. If the grade is greater than or equal to 60, then you pass. Okay, so sample display. So input the name. So you need to input the name and score. Okay, like for example, no, John, and John got 66, no, in his grade, and then it will display John 66, then pass. Okay, so let us do this, no, in flowchart. All right, so this is the flowchart. Okay, all right, so the flowchart, as usual, it will start with the start symbol. Okay, and then now it will declare, no, the variables, okay, using this preparation symbol, no, the hexagonal shape. Okay, like that. Don't forget the arrow. And then here it says name. Okay, name. No, I will enlarge this one. So name equal to, you can see a double quotation. Okay, why there's a double quotation? Double quotation, it refers to the, no, refers to a string. Okay, it refers to a string or a character. Okay, because you're going to input a, a characters, no, or a string, not a number. Okay, so that's why he uses this double quotation in the name. But in the grade here, as you can see, grade equals to 0. Okay, he initializes or he prepare or initializes or he declared that the grade variable is equal to 0. Okay, and then the rem is the remarks, no, it refers to the remarks. So what is the remarks, no? If it is pass or fail, so meaning it's a word, no, you're going to input a word or a string, so that's why it uses a double quotation here. Okay, I hope that is clear. Then after that it will go to the input. Okay, this input. Okay, input symbol. So you need to input the name and grade. All right, then once you input the name and grade, no, remember in our example we inputted John 66. So John is the name and 66 is the grade. All right, and it will go in this symbol. Okay, what is this symbol again? Can anyone tell me what is this symbol? This diamond shaped symbol, what is this for?
Decision.
Decision symbol. Okay, correct. So here it will ask, no, it will say if your grade is greater than equal to 60. Okay. No, greater than equal to 60. So if it is true, if your grade is greater than, okay, or equal to 60, if it is true, then it will process rem is equal to pass. No, this is the process. Okay, rectangular shape. So meaning the value of rem is equal to pass. Okay, like for example, no, John 66. So John got 66. So meaning to say John has a grade greater than 60. Okay, so meaning it's true. Then his remarks rem is equal to pass, and then it will display using the output symbol. So it display the name, which is John. Then it will display the grade 66, and it will display the rem. What is the rem? What is the rem of John? Anyone? What is the rem of John? Girls. Anyone can make a guess? You have the name, John, and the grade 66, and the remarks, the rem. What is the rem of John?
True.
True. So rem is? What is rem? Now, what is
Pass.
rem equal now? Pass. Correct.
Pass.
Pass. Okay? Then stop. Okay? Okay, then stop. All right. Okay, for example, if let's say John got 50, okay, so what will be the display output?
Fail.
Okay, it will say, it will print John 50 fail. Correct? Correct. No, why? Look at here, no, in the decision, Now the name is John, but the grade is 50. So the grade now, is the grade greater than equal to 60? True or false? Tell me. For this input,
False.
is the grade greater than equal to 60? Is it
Less.
true or false?
It is true.
True?
False.
False.
False. It's false, no? Because the grade 50 is not greater. No, this is not greater, no? This is not above 60. This is below 60. So it should be less than, no? So this is false. So false. So that's why your RAM is fail. So John 50, it will print now the John 50 fail. Okay? I hope that is clear, no? All right. Okay, moving on. Any questions regarding this if else?
No.
No questions? Okay, good. So let us go to the next one. Same, it is an if else or decision flow charting. Okay, this time we're going to uh, uh, performance of an employee. Okay, so let me read. So draw a flow chart. Draw a flow chart that will ask the user to input the name and score of an employee. So the algorithm will then print the name and the score of the employee as well as the remark about their performance. Okay. If their score is between 4.5 to 5.0, then it is outstanding. Okay. If it is 4.0 to 4.5, then it is very satisfactory. If it is 3.5 to 4.0, then it is satisfactory. And if it is 3.0 to 3.5, then it needs improvement. Okay? If it is less than 3, then it is poor. Okay? So sample display. No? For example, the input name is James and the score is 3.2. So if it is 3.2, so where is it belong? If it is belong here, no? Between 3.0 to 3.5. So that is needs improvement. Okay? So James 3.2 needs improvement. So that's the displayed output. Okay. So the flow chart is like this. Okay. Okay, I hope it's not too much small, no? I hope that you can see it properly.
It's not clear there.
I cannot hear you. Okay. So here, let me, okay. So here start, okay, and then declare using preparation. Okay, so the name, okay, with the double quotations, and then score start with 0, then RAM is equal to the double quotation. Okay, so this is the preparation. Just the second step, no, of the algorithm and flowchart. And then next, you need to ask the user to input the name and the score. So we inputted the name, that is James 3.2. Sa? Okay. Now we will going to make a decision symbol. Okay, I'm going to use the decision symbol, and let us start if the score is less than 3. Then if it is true, if it's less than 3, then your remark is poor. Okay, so this is process, huh? So the rem is equal to poor. Okay, if less than 3. Then if it is less than, the score is less than 3.5, okay, 3.5, let's say 3.2, then if it is true, then RAM here needs improvement. Okay, needs improvement. So once it's true, it will go through here and it will go through this display name, score, and RAM. Okay, so display name James, score, that is 3.2. Then the RAM, okay, this one, no, the RAM needs improvement. Okay. Okay, what if James got, let's say, what if James got 4.2? So what will be the James performance if it is to 4.2? Look at the flow chart and the condition where it will be belong. Where this will be belong to? Tell me. Can anyone tell me? Which one? Is it satisfactory? Is it very satisfactory or outstanding? Which one? Which of the three? Which one? This one, 1, 2, or 3?
Outstanding.
Outstanding. Okay. Okay. Actually, it's not outstanding. Huh? So this is 4.2. Okay. So let us try one by one.
It is
So
satisfactory.
score less than 3. Is the score less than 3? No. False. Is the score less than 3.5? No, because this is 4.2. False. So it will go here. Is the score less than 4? No, false. So it will go here. Is the score less than 4.5? Yes. Yes. So it's true. So it will, the remark is very satisfactory. So it will print now James 4.2, then very satisfactory. Okay, like that. Clear, everyone? Is it clear? Girls, is it
Yeah,
clear?
clear.
Okay. Okay. All right. So we already done the sequence. No, I already give example for the sequence, and the second one is the selection using the if else or the decision. No, and then the last is the loops. Okay, the repetition. Okay, repetition construct of the flow charting. All right. Okay. Draw a flow chart that will print the numbers from 1 to 10. So the display, it will display 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it will display from 1 to 10. Okay, so it will print the numbers from 1 to 10, like for this example. Okay, so what will be how are we going to make a flow chart on that? Okay, so it will be like this. Okay, there are two ways or two solutions to solve that problem. Okay, so we have solution 1 and solution 2. All right. Okay, which one you want you want me to do first? Solution 1 or solution 2?
Solution 1.
Okay, 1. Okay. Solution 1. Okay. So now we will start. So start using this oval shape and then go to the preparation. So this preparation, we declare that x is equal to 1. Okay. So we'll start x is equal to 1. All right. Then it will go to the decision here, no? Decision symbol. Okay. Here, there's a condition, no? It says if x is less than equal to 10, then true. If not, then false. Stop. Okay? Now remember, our x initially is equal to 1. Okay? Equal to 1. So now it will ask the condition. Is x less than equal to 10? True or false? Is it true or false? Girls, is it true or false? Is our x is less than equal to 10? True or false?
So it's it is so it would be true.
It would be true. Okay?
Yes.
So imagine, no? X less than equal to 10. Okay? Remember we declare that x is equal to 1 here, no? In our preparation. So meaning x here is 1. So 1 is less than equal to 10. Yes, true. Okay? So if it is true, then it will display the value of x using this output, no? This is output symbol, no? Output symbol. So display x. So display x. What is the value of x? 1. Okay. So it display 1.
Equal 1.
Okay. After displaying it, it will go to this process symbol. Okay. In the process symbol, there's an equation, no? X is equal to x plus 1. Okay. So remember, our x, no, our x is 1, then plus 1, then it will become 2. So now x here is equal to 2. Okay? Why? Because initially our x is equal to 1. Then we added another 1. Then it will become 2. So then after that, it will go back, no? Like that. Here. In the decision. In the condition, no? Or decision condition. So now it will check. So this time, x is equal to 2. So is x equal to 2? Is it less than equal to 10? True or false?
True.
Tell me. True. Then if true, it will
Would be
display the x, which is 2. Like that. Okay? Then after that, it will undergo this process again, no? So 2 plus 1. So 2 plus 1. Now this will become 3. Then it will go back here. And this will become 3. Okay? Is 3 less than equal to 10? No? From this decision?
True.
True or false?
True.
True. Then it will display, no? The value of x, which is 3. Okay? Okay, I will erase this. Okay? Next. So now, x now is 3. So now, 3, no, from the process here, no? Here, 3 plus 1 equals 4. So now it will go back again here, and the value of x is equal to 4. Okay? Is 4 less than equal to 10? True or false? True or false?
True.
True. Then it's displayed the value of x, 4. Okay? And then it will add, no? So now the value of x here is 4 plus 1 is equal to 5. Then it will go back here, no? It will do some looping. Then here x is equal to 5. Okay? So is 5 less than equal to 10? Yes, true. Then it will display the x, which is 5, here. Okay? And then x now, no, from this process symbol, 5 plus 1 is equal to 6. Okay? So x here will become 6, no? So it will go back here. Okay? Then it will check again the condition. 6 is less than equal to 10? Yes, true. Then print the value of x, 6. Okay? Then 6 plus 1. 6 plus 1 now, how much? 7. Sa? So here it becomes 7, no? So it will go back here. The value is equal to 7. It will check the condition. 7 is less than equal to 10. Yes, it's true. Then it will, okay? And then after that, no, after that, it will check the process here. So 7 plus 1 equals 8. And then it will go back here. It will going to check the condition. Is 8 less than equal to 10? Yes, still true. Then display the value of x, which is 8. Okay? And then process again. So 8 plus 1. Now it will become 9. So the x now will become 9. Then it will go back here again. Then it will check it is if 9 is less than equal to 10. Yes, it's true. Then display x, that is 9. Okay? And then after that, it will process. So 9 plus 1 equals to 10. So x now is equal to 10. So it will go to here. It will check. Is 10 less than equal to 10? True or false? Girls. Is 10 less than equal to 10? True or false?
True. Because it's
True.
less than.
Yeah. Yes, because of this equal sign, no? So still true. So when it's still true, it will display the value of x, that is 10. Okay? Now, it will process. So 10 plus 1, 11. Okay? Now, it will check the condition. Is 11 less than equal to 10? True or false? Is 11 less than equal to 10? True or false? Girls. Is 11 less than equal to 10? Is it true or false? Is it true or false? Tell me. Is it true or false? Anyone? Oi. Anyone cannot answer this?
Sir, it's false. False.
Yes, it's false. It's false, no? 11 is greater than 10. No, it's not less than. It's greater than. So it is false. So it will stop the flow chart. Okay? So now the final answer is this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, got it? Clear? Girls, is it clear? Yes or no?
Yes.
Someone say yes. Very, very tiny voice. Okay. I think silence means yes. Okay.
Yes, sir, clear.
Okay. How about solution number 2? Solution number 2. Can anyone answer solution number 2? Can anyone uh, or can anybody volunteer? Can anyone volunteer to explain solution number 2? Hmm. Nobody. Okay. 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 Let us do the solution number 2. Okay. So this is another way how to arrive this final output. Okay. This is another solution. Okay. So here in the solution number 2, of course, no start. Then the preparation x is equal to 0. Unlike here in solution number 1, x is equal to 1. Okay, what if we start with x equals to 0? Okay, then it will go to this condition. Is x less than 10? Now the equal sign is not there anymore. Okay, remember, the equal sign is not there. Okay, it's only x less than 10. Okay, then it will check. Is 0 less than 10? Yes, true. Once it's true, it will process this equation. Okay, this increment equation. So x equals to 0 plus 1. Okay, 0 plus 1. Remember, our x initially is 0. So 0 plus 1. So x is equal to 1. Then display using this output symbol. So it will display 1. Okay, x is equal to 1 now. Then it will go back. Okay, like this. It will do a looping. It will go back to the condition. Is 1 less than 10? Yes. Then process 1 plus 1 equals 2. Then display the x, which is 2. Like that, no? Then it will go back again. And then it will check is 2 less than 10? Yes. Then it will, yes, true. Okay, and it will process 2 plus 1 equals 3. So x is equals 3, then display the value of x, which is 3. Okay, and then it will go back. 3 is 3 less than 10? Yes, it's true. Then process 3 plus 1 equals 4. Then display the value of x, that is 4. Okay, and it will go back again like this. Okay, and then it will check, is 4 less than 10? Yes, it's true. Then x is equal to 4 plus 1. Then it will become 5. So x now is equal to 5. Then display the value of x, that is 5. Okay, and then it will go back and check the condition, is 5 less than 10? Is 5 less than 10? Yes, it's true. Okay, then process 5 plus 1 equals 6, and then display the value of x, which is 6. Okay, and then go back, check the condition again. Is 6 less than 10? Yes, it's true. Then 6 plus 1, 7. So display the value of x, which is 7. Then it will go back here again. Is 7 less than 10? Yes, it's true. Then 7 plus 1, which is equal to 8. So x now is equal to 8. So display the value of x, that is 8. Okay, and then it will check, the condition here again. Is 8 less than 10? Yes, it's true. Okay, so process 8 plus 1 is equal to 9. Then display the value of x, which is 9. Okay, and then it will go back here. So is 9 less than 10? Yes, it's true. 9 is less than 10. Then process 9 plus 1, which is equal to 10. Okay, and then display. So display the x, which is now equal to 10. Okay, and then it will go back again. Check the condition. Is 10 less than 10? No, it's false. No, 10 is equal to 10. No, they're equal, not less than. So if it is false, then it will stop the flowchart. So you will be arriving the same output in solution number 1. Okay, is it clear? Everyone?
Clear.
Clear. Okay.
It's clear.
All right. So let us go now to the next. Okay. So loops again. So draw a flowchart that will print the area of a circle when the radius r takes values between 1 and 5, and the area of the circle is pi r squared. Okay. So sample display. So when your r is equal to 1, the area is 3.1416. When r is equal to 2, the area is 12.5664. If the area is equal to 3, the radius is equal to 3, or the r, the area will be 28.2744. And if the radius is equal to 4, then the area is 50.2656. Okay? And if the radius equal to 5, the area of the circle is 78.54. Okay, so let's have a look on the flow chart on this. Okay, all right, so there is 3 solutions, no, to do the flow chart. 3 solutions. Okay, so remember, you have this sample display. Okay, sample display. All right. Okay, let me better to put it like this. Okay. Okay, let's answer solution number 1. Okay. So now here you have here start, and then declare the variables with its value using the preparation symbol. So pi, no, pi or pi, or pi is equal to 3.1416. Sa? No, the pi symbol, no? No, like that, no? The pi symbol. And then r, no, initializes or declare r equals to 1. And then area, variable area. So you have variable pi, which is equal to 3.14, and variable r is equal to 1. Okay, and the variable area. Okay, so first it will undergo a process here using this process symbol. Okay, so here it says area is equal to pi, no, like this, no? I will rewrite that. Area is equal to pi, the multiplication, then r times r. Okay, why is it r times r? No, actually you can do this, no, in mathematics, no, r squared, no, but in flowcharting and programming, this r squared is not, no, it's not an option. Okay, meaning is you cannot do this, no, in the C++ programming or in flowchart. Rather than you need to multiply by itself. Okay, by multiplying by itself, no, r times r. Okay, so this is similar to r times R. Okay, like that. All right, so let's us get the first area. Okay, so let us put it here, R area. Okay, so R, no, when R is equal to 1, no, here, R equals to 1. So what will be the area? So here it will say 3.1416 times 1 times 1. So it will become 3.1416. No, the area is 3.1416. So 3.1416. Okay, so the area is equal to 3.1416. All right. So after processing it, it will print, no, the R, which is 1, and the area is 3.1416. No, this is the output. Okay. After processing, and it will print or out the value of R and area. Then after that, there's another process. Okay, another process, this one. So this process is equal to, remember our R is equal to 1. So R is, this is 1, so 1 plus 1. So now our R is equal to 2. Okay? And then it will undergo with the decision, which is R is less than equal to 5. Okay? Or remember our R here is equal to 2. So 2 is less than equal to 5. True or false?
True.
True. So when it's true, this arrow will go back here. No? Because it's true. Then it will gonna process the value of area, the new value of area. So what is the new value of area? Remember our
2.
R is 2. So you can say here area, okay, pi is 3.1416 times, now this is 2 times 2. Okay, so what will be the value of area? The new value of area. Tell me.
12.664.
Okay, so 12.5664. Okay, so we can write it here, no? And then after taking the area, then it will print the R and area. So R is 2 and the area is 12.5664. Okay? Then after that, what will happen? It will go to this process, no? So remember our R is equal to 2. So 2 plus 1. So this time R is equal to 3. And then it will check the condition here, no, in the decision symbol. So is 3 less than equal to 5? Yes, it's true. Then it will go back here again. So this time area, no, it will process again this one, no, it will process this. Area is equal to 3.1416 times 3 times 3. So what's the value of area? Tell me.
28.2744.
28.2744. Okay, and then after that, after processing it, it will display, you know, or print using the output symbol. So 3, print the R and area, that is 28.2744. Okay. Then after that, what will happen? It will go to the process again, no? R equals to R plus 1. Okay. So now remember, the value of R initially is 3. So 3 plus 1, now it will become 4. Okay, so R is equal to 4. Then check the condition. Is 4 less than equal to 5? Yes, true. Okay, it will go back here. So now area is equal to, then it will process, no? Okay, process the area, the value of area. So 3.1416 times 4 times 4. So what will be the new value of area? What will be the new value of area?
50.2656.
50.2656. Okay. Then it will print, no, the R, no, using this output symbol. So 4 R, then 50.2656. Okay. Then after that, it will undergo a process again. So the R is equal now to 5, 4 plus 1 equals 5. Okay. This will become equal to 5. So is 5 less than equal to 5? Yes, true. Then it will go back here again and then process the area. Okay. All right. So area now is equal to 3.1416 times 5 times 5. So what will be the value of area? Tell me, what will the value of area?
78.54.
Okay, 78.54. Okay, and it will display, no, it will print the output using this symbol. Okay, so print R 5, then 78.54. Okay, and then it will increment the R. So R now 5 plus 1, it will become 6. Okay, once it becomes 6, it will check the condition. Is 6 less than equal to 5? True or false? True or false?
False.
Is false. Okay, and it will stop the program. Okay, clear? Is this clear, girls? So let us start the solution number 2, no? Because we done this already last time, no? So same thing in a characteristic of a repetition or loops. If the condition, no, here, no, if the condition here is true, then it will keep repeating, no? It will keep repeating like that. And if it is false, if this condition is false, then it will stop the program or the flowchart. Okay, so let us go to this one. No? So start solution, then declare using this preparation symbol. No? So declare pi is equal to 3.1416 and r is equal to 1 and variable area. Okay, without any value. Okay, so now, so initially it will says here, no, is the condition says is r is less than equal to 5. Okay, remember that r is equal to 1. Okay, so I will put here like this, no, r, then area. That, no? So r is equal to 1, then it will check the condition. Is r less than equal to 5? True or false? Girls, can you tell me? It's r is less than equal to 5?
Yes.
True. Okay. So once true, you can see here, no, the process symbol, no, process, no, this is a rectangular shape, meaning it will execute this formula. So area now is equal to pi 3.14 times, remember r is equal to 1 times r equals to 1. So pi 3.14, 3.1416, okay, 3.1416 times 1 times 1, no? So the area is 3.14. 14, 16. Okay. Okay, 1 minute. Okay, 3.1416. Okay, got it? Okay, so let's go to the next one. So now here, as you can see, no, it will print R and area. So that's why here, no. So we print R1 and we print the area 3.1416. Okay. Now next, another process, no. So it will encounter another process. This process will now uh, going to increment, no, the value of R, okay, by 1. Okay. So now remember that our initial R is 1. Okay. So R, which is 1 plus 1, then this will become 2. All right. So it will go back here. Okay. Then it will check is is R less than equal to 5, where R equals to 2. True or false? Is it true or false?
True.
Girls, can true. Okay, good. Then whenever it is true, then this area will be processed, no? So pi, it is 3.14 times 2 times 2. So how much it will be? Times 2 times 2. Can you tell me how much? Anyone? Anyone can tell me how much it is? 3.14 times 2 times 2. How much? Get your calculator.
12.56.
Okay, 12.56. Okay, so now it will print, no, using this print symbol, no? So print R, that is 2, and area, that is 12.56. Okay, so now it will go to this process, no? After printing it, it will go to this process. So remember, our R is equal to 2. So now R, which is 2 plus 1. So what will be the value of R now? The value of R is 3. So it will go back here, no? It will check now. Now we see the arrow is pointing here. So it will check the conditions again, no? So is R less than equal to 5, where R is equal to 3?
Yes, true.
Yes, true. Correct. Then it will process again. Then it will multiply, no, the 3.14 times R, no, where R is equal to 3. So how much? 3.1416,
28.26.
28.26.
26.
Okay. All right. So now it will print, no? So 3. So this is 28, sorry, point 26. Okay. All right. Then after that, R is equal to R plus 1. Remember, our R is 3. So 3 plus 1, it will become, how much the R now?
4.
4. Okay. So now it will go back here. All right. So the condition. Okay. So is R less than equal to 5, where R is equal to 4?
True.
True, right? Yes, correct. Then it will process, no? So area now is equal to 3.14, which is pi, 3.1416 times 4 times 4. So how much it will be? The area?
50.24.
50.24. Okay. So now it will print, no? 4.24. Okay, and then it will increment, no, the value of R because of this process. So now 4 plus 1, this is 5. Okay, now it will check the condition. Is R less than equal to 5? Where R is
True.
equal to 5? True. Yes, true. Why? Because there's still equal here, no?
Equal,
No, as
yes.
you can see, no? Less than equal to 5. So it's true. So this will be processed, no? So area is equal to 3.14 times 5 times 5. So how much the area now? So print R, which is 5,
78.5.
78.5. Okay, then it will process the R. So R is equal to 5 plus 1. So this
6.
R will become 6. Okay, so it will go back here. Is 6 less than equal to 5?
False.
False.
False. So now when it's false, then it will stop the program or stop the flowchart. So this is your answer. So the same answer what we got in solution number 1. Okay, is it clear, everyone?
Yes.
Clear.
Okay, okay. All right. So I'm going to delete this, okay? No need, no need. Okay, so let's go to this solution number 3. Okay, solution number 3. Okay, similarly, you will going to declare, no, or prepare, no, the 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 variables and its values, no, prepare or initialize. Okay, now we have here pi 3.1416. Okay, all right, and now this time it will start at r equals to 0. Okay, r equals to 0, and the area still the same, no? Okay. Now, before we go to solution number 3, now try to compare these two flowcharts. Okay, what's the difference from them? Because here the declare they are the same. Okay, what are the difference from solution 1 and solution 2? Can you tell me? Can anyone analyze and what is the difference between these two solutions?
The sequence for the
Okay, the
condition.
sequence or the condition. Okay, so yes, you're correct about that. The sequence, of course, no, is quite different, no, because here in solution number 1, uh, he do some process, no, and printing before the condition. Okay, but here condition first before process. Okay, that's the main difference. But now in solution number 3, what will be the difference between the two solutions, no, between 1 and 2?
The process
Anyone?
and then the condition.
Yes, here you increment first the r, okay, then condition, and then what you call this, and then the process, no, here. So incrementing first, then condition and process. Okay, but they will arrive the same answer. Okay, because this time we no he uses r, no, he decided that r is equal to 0. Okay, so now r is equal to r plus 1. So meaning 0 plus 1. So r will become 1. Okay. Okay. So I'll write here r then area, no, so that later we can. So r equals to 1 like that, no. So it will check the condition. Is r less than equal to 5? Yes, it's true. Then it will process. So area is equal to pi, this is 3.14 times 1 times 1, no? So it will print the r, 1, and the area. The area is 3.1416. Okay? After printing it, it will go back here, and it will increment the r. So r, which is 1, then plus 1, then this will become 2. All right? So it will check the condition. Is 2 less than equal to 5? Yes, it's true. Then area now is equal to pi times 2 times 2. Okay? Remember, pi is 3.1416. So 2. So now the area is 12.56. No, it should be same as this. Okay? Same as this. Okay. All right. Then print the area R and the radius r and area. After that, it will go back to this condition. So now r is equal to r plus 1. So 2 plus 1, what's the value now of the r? So now r here is equal to 3. So is 3 less than equal to 5? Yes, it's true. Then area is equal to 3.14 times 3 times 3. Then it will print the r, no? 3. So that is the area is 28.26. Okay. And then increment the value of r, no, from here. So 3 plus 1 equals 4. It will check the condition. Is r equals to 4 is less than equal to 5? Yes, it's true. Then area, process now, area 3.14 times 4 times 4. So 4 here is equal to 50.24, no? Like that. And then it will go back here. It will increment the value of 4. So the value of 4 now, 4 plus 1 equal to 5. Then it will check. Is 5 less than equal to 5? Yes. Then area 3.14 times 5 times 5. So how much is it? So 78.5, no? 5, no? Same as here. And then if the r is equal to 6, no? So 6 is less than equal to 5? No, it's false. Then it will stop the flow chart. Right. So is this clear? I'm going to show to you how to draw a flow chart, no? How to draw a flow chart in www.draw.io. Okay? And implement the flowcharts in the previous slides, and please publish your work as URL and share your work with the instructor. Okay, but first I need to teach you how to do the flowchart, no? uh, using the what you call this, draw.io. Wait a minute, control and click. Okay, so if you type this in the web browser, no, please use the Chrome, okay, Google Chrome, HTTPS, this one, no, www.draw.io, okay, and put it here, no, here, okay. Once you've done it, then just put here decide later, okay. No need to choose anyone here, just decide later, okay. So once you go to that website, you will be redirected in this kind of a environment. Okay, so from here you can see that at the left side you will see the general symbols, no, general types of symbols that are for a certain flow chart. Okay, we have the process, the rectangular, this one rounded, no, do not use this one in start and stop. Okay, I prefer this one, the ellipse. Okay, that like an oval shape. Okay, and here this one is for the process. Okay, this one is not this one, not this one process. Okay, um, in programming we are not using this one. This one we use it as a function. Okay, for the function, but this one rectangular is for the process. Okay, we have this preparation. Yeah, this the diamond. Okay, and we have this the arrow here. All right. So let us draw one example. Okay, let me try this. Okay, to show to you how to use this flowchart www.draw.io. Okay, so let's try this solution number one. No? So start, then diamond, process. Okay, okay. So I'm gonna use this. Just drag and drop. Okay, drag and drop. And for this, you can also, no, like this, no, you can change, no, the size, no, you can make it smaller if you want, like that. Okay, and then after that, I need the preparation. Okay, I'll make it a little bit like that. Okay, okay, and then after the process, I mean preparation, so you need to have a process, no, the rectangular shape. So like that, no, add drag and drop. Okay. Okay, and then what else you need? Input, then process. So input, this one, the parallelogram. Okay, and another process. Okay, sometimes actually you can also do by clicking, no, clicking the symbol, it will automatically, no, show here in the sheet. Okay, okay, like that. And after that, I think decision symbol or the condition, and then uh, the stop, no, the stop symbol. Okay, like that. Okay. So now what we will do is that, okay, we're going to connect it. Okay. So how to connect, no? Just okay, let me okay, just put your cursor near to the bottom here, no? So anywhere actually here, here. No? You can put it there, no? But I prefer it here, no? Because we are going to point down an arrow, no, on it. Okay, there are two things to put an arrow, no? It's either you will use here, like this, connect using directional connector, or you can do it from here, no? So when you put your cursor near to this point here, no, and it's turned into green, then just click and hold. No? Click and hold your mouse. No, left click and hold your mouse and drag it like that. Okay, then the arrow will show up and connect it, no, to the next. Okay, to the next symbol. No, once you see that there's a green color, meaning you are now connected. So then release your mouse. Like that. Okay. Similarly here, like that. Click and drag, like that. Also here as well. Okay. And here as well, like that. And okay, here and here. Okay. Okay. Am I correct? So let us check if it is correct. Yes. No. One, two, three, four, like that. No. And then from the decision, from this side, it will go back to here, not to the process. Okay. So from decision here, just click it again like that. No, and you go back here, no, to the process, no, then you can move. Okay, you can move the arrow, no, like that, no, like that. Okay, so now your flowchart is complete. Now we will put the algorithm on it. So of course the first is for the start, type start. Okay, so how did I do that? So let me just double click on it, no, double click the symbol, and it will, the cursor will appear, and type start. That, no. Next, the preparation. So what will we prepare? So declare pi 3.1416 r. Then okay. So no need to write declare, huh? Just type pi, no, equals to 3.1416. Okay, and r is equal to 1. Then area. That. Okay. Then next, the process. So what will be the process? Area is equal to pi r times r. Okay, so we can say here, you can type area is equal to pi star. Okay, remember, no, use the star r star r. Okay, pi times r. All right, and then for the output, print r and area. So here, print. Okay, you can use output or display or print. Okay, so print R and area. Okay, no need to put n, no, because you are doing algorithm. Okay, what we will do, comma. comma will do that. Okay, then process R is equal to increment the R, no? Is equal to R plus 1. That, and the decision is should be R is less than or equal to, and here stop the flowchart. Am I correct? Yes. So here you go. No, this is your first flowchart. No, draw. No, in the okay. Now actually you can click here to save. No, like that. No, save in your device or in Google Drive or whatever. But actually I am not requiring that. No. Okay. So what I am requiring from you, no, especially in the exam, no, in the test. Okay, in the test. So what I'm requiring you is that uh, it will, uh, especially in the exam, no, or midterm exam and the final. So what I'm requiring for you is to publish a link. Okay, publish a link. Okay, so here, no, publish your work as URL and share your work to the instructor, no. So normally it's like that, no. We are requiring from you. So how to do it? Okay, how to do that? So you go to file. Okay, please pay attention on this because I'm not going to repeat this one on the next lesson. So just file, export, no, not export, publish here. So again, file, publish, click the link, okay, and then don't change anything, just click create, all right, and then copy, click copy, okay, to the clipboard. Okay, once you copy it, okay, if you have a Word file there, no? If you have a Word file, sorry, if you have a Word file, okay, or your laboratory or the exam test, just Control V, no, or paste it. Okay, okay. For me, my Word file is not activated, so Notepad. I'll use Notepad. Just then, paste it. Okay. So this is your link. Okay, this is your entire link. Okay. Now to view again your work, no? If I want to view your work, I'll just copy your link. I'm gonna copy it like that. Then I will go to the web browser and paste it, no, in the in here, no, in the URL like that, no. And then I'll click enter, and then it will generate now my flowchart like this. Okay, did you follow, girls?
Yes.
Okay, so again, what you will do, file, publish, link, create, then copy. Okay, for example, no, you're doing an exam, no, in VB Learn, then just copy it, no, just copy because in exam, in any exam or quizzes, no, I will allowing you to, if it is lockdown browser, but it will allow you to go to this web page, no, or this software, so that you can create your flowchart. And then to put the answer, no, in the BB Learn, then you need to go to File, Publish, create the link, and copy the link and paste it in the Blackboard. Okay, like that. All right. Is it clear, everyone?
Yes.
Okay. All right. So let us go. Let us do another one. No. Okay. Okay. Let us do this. Okay. This one. Okay. So I'll go back to where is it? Okay. I'll go back here. Okay. Now I will create file new. Okay, I will create new flowchart. So new, like that. I'll do the blank. Okay. So now I have another tab, no? Tab for the flow chart, no? Drawing another flow chart. Okay, so from here, so I'm here right now. So I'm going to draw this one. Okay, so start, then preparation, then input. Okay, so here start, that, then preparation, then input, and then decision. Okay, so I'll make it a little bit smaller. Okay, decision and what else? Okay, process for both sides, like that. Another one here, process for both sides. Okay, and then print, then stop. Okay. Okay, another tip, no? Another tip, how to, in order for you to, okay, to make the flow charting drawing fast is that if you are given a problem, no, later on, okay, so just, for example, no, make a flow chart to 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 tell if the number is odd or even, no? Odd or even number. Okay. So what you will do is that draw it first in the paper. Okay. Make a draft first before you go here, no, in the draw.io, no, so that it will be faster. No, you will have you can choose directly, no, the symbols that you're going to use. Okay. So that's my tip for you, no? Hint, so that it will be easy. Okay. So now I'll put here start. Okay, in the preparation. So preparation name. So name equals then double quotation like that. Else grade and rem. So grade is equal to 0. And rem is equal to double quotation, no? Because rem it means remarks, no? So it is implicate for the what you call this words or string or characters. Okay. All right. So we forgot to put an arrow. So I'm gonna put an arrow like that, 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 and this one like this. Click and drag, no? Okay. It's either here like that, no? Okay, that, and here like that. Okay. Okay, you can adjust a little bit by dragging it. Okay. So here, input name and grade, no? So here, input name, grade. Okay, so you can adjust a little bit so that the words will be shown inside, no? And here the condition, grade is greater than equal to 60. Okay, so here it says grade is uh, greater than 60. And if it is false here at the left, true at the right. Okay. So now to create a word here, no, all you need to do is back to the general and look for the text. Okay, text like that. Click it, it will show like that and drag. So here you can say this is false. Then the other side here will be true. No? True or false. Like that. And here, rem is equal to fail, no? Fail. And here, rem is equal to pass. Just this one a little bit. Okay. All right. So now, here you can say print. Okay, print the name. Okay. Name, then rem. Grade as well, no? Name, grade, and rem. Okay, like that, no? And here, of course, no, the stop. Right. So now this is my final flowchart. And now I can go to File, Publish Link, Create, Copy. Okay. Then I'm going to paste it, no, in a Word, no, or whatever, no, in maybe in the in a in VB no, or in a Word format. Then I can go to these also to the web browser and paste it like that. And then it will show me the flowchart, okay, that I have been created just now.